This is question 5 of the natural log homework from the CEMC exercises. Question 5. The natural log of x when x has got the value of e. Let's find the y coordinate when x has the value of e. So y is going to be the Euler number e over the natural log of e. So the Euler number is the Euler number. The natural log of e is actually 1. So e to the exponent 1 is equal to e. So it's e over 1.
Cole and crew Catley to the office for pickup, please. Cole and crew Catley to the office for pickup, please.
So basically, the y coordinate is also the Euler number. Okay. We have our x and our y coordinate. Now we just need to go after our slope. And of course, we're going to go after our slope by taking the derivative. So y primed, I am going to use the quotient rule. So bottom, natural log of x, times the derivative of the top, which is just x. The derivative of x is 1, minus the top times the derivative of the bottom. So x times 1 over x, which is the derivative of the natural log, all over the natural log of x. And this is squared because it's the quotient rule. Okay, I can simplify this. This is the natural log of x. And x times 1 over x is 1. Subtract 1 all over the natural log of x squared. Now that we have, this is pretty simple for the derivative, but now that we have it, we can plug in our x coordinate and find the slope when x is equal to the Euler number. And so the natural log of the Euler number, subtract 1 all over the natural log of the Euler number squared. And so we've already seen that e to the exponent 1 is the Euler number. And so this is actually 1 minus 1 on top divided by 1. And so the slope is 0. This is actually a horizontal line. And the CEMC materials do not identify it as a horizontal line. So there's a problem. Anyways, the slope is 0. Now, the second thing, they're usually using the point slope form of the line, which is to say, that's where you say, well, y minus whatever the y coordinate is over x minus whatever the x coordinate is, in this case, also the Euler number, is equal to the slope, which in this case was 0. And so they're always taking this point slope form because it's easy, and it is a nice lazy way of doing it. They're always taking that point slope form, and they're just giving you the equation of the line sort of with the point slope form manipulated. Of course, this simplifies to y is equal to the Euler number, and it looks something like this. It's the actual equation of the tangent when x is equal to e. Oh, also has a value of e. Anyways, it looks something like that. So there we go. Find the y coordinate. Take the derivative, find the slope. Put it into this slope point slope format, and then solve. In this case, the answer is different to the one that was given in the CEMC homework. The next one we can do largely the same way. There is a small trick in it, and maybe I'll just go over the trick to start with. When you go to find the y coordinate, you'll run into the first trick right away. X is equal to 1, and so y is going to be equal to 1 over 1 plus the natural log of 1. Okay, so natural log e raised to some exponent is equal to 1. What exponent? Anything raised to what exponent is always equal to 1? It's 0. And so this actually simplifies to 1 over 1 plus 0 or 1. So x is equal to 1, y is equal to 1. There are the x and y coordinates for our point slope form. And then take the derivative of this. It's going to look terrible until you go ahead and plug in a 1 for x, and a bunch of stuff just turns into nice, easy numbers. Anyways, There's question 5 of the CEMC homework. A is done, B is started, and C, well, I'm just not going to talk about C.